Hi, this is Jeremy Bredden with Chorus Chord Software Solutions. Today I'll be showing the second video of Dwarfcraft, which is a small experimental project I've been working on for the last couple of weeks. It's both a mix of Minecraft graphics and then also Dwarf Fortress gameplay. The idea is that the world, much like Minecraft, is generated using a series of discrete cubes, and then also the gameplay is like Dwarf Fortress in the same sense that instead of manipulating the world directly, you're using dwarves as almost like a real-time strategy game to tell them what to be doing, and then also you're trying to support the colony for the game. So you'll see that the graphics may look familiar if you've played Minecraft. Right now the textures are directly from the Minecraft terrain image. The main reason why is, hey, I'm not an artist, but I really like programming and I just wanted to get this up and going. You could go ahead and translate with the right mouse, and you could select things with the left mouse click. You could zoom in and out using a FOVI slider, and then also you could change the cutoff, which isn't a feature in Minecraft, but is very important to Dwarf Fortress. What the cutoff is the amount of blocks from the very bottom to your cutoff level that you want to render. So if I go ahead and change this, you'll see that I'm going up and down the content of the valley. If I zoom out a little bit more, I could show you actually the size of the full world without any cutoff, which is about 128 cubed. If we go ahead and zoom back into the base of the level, let me just translate, lower the depth. Here we go. I could go ahead and create little monsters by holding by pressing the left button. These monsters come from a texture within Ragnarok Online, which is an online MMORPG from a while ago. Right now I'm just using it as kind of a test proof of concept. The other really important thing about the current state of the code is that this entire world is generated by a combination of Perlin noise masks, as well as is saved using an octree. So I've mentioned before in previous videos how octrees work, but again, this is just to emphasize how important they are. So this world, which I've mentioned before is 128 cubes cubed, would normally take up a huge amount of memory if it was directly allocated as one giant cube. To save memory and also seek time, what I've done is I've created an octree, and the octree chunk size is 16 by 16 by 16 cubes. So that means that any place that we actually have game data, so maybe one of these monsters or maybe parts of the game scenery, we go ahead and allocate that chunk. But if the chunk has no data or is maybe full of air or non-renderable blocks, then it's actually not rendered and saved in memory. Also, don't forget that this data representation is within main memory and not the graphics card. For the graphics card, the memory is represented as individual rows for each row of the world. So each row is built as a series of faces within a vertex buffer object. That way we could very quickly render the entire scene. There's no complex overhead of pushing geometry to the graphics card at runtime. And then also we could slide up and down very quickly, so hiding one or showing another level. You'll also notice these black borders right at the side. Let me see if I could zoom in a little bit, which represent any sort of geometry right above the current location. The whole idea here is that it's supposed to help players distinguish areas that have yet to be dug out or areas that might have objects right above them. Since the whole idea is that we want players to dig through the game, the benefit of this cutoff system is we could quickly let them see the worlds being cut through so that they could see any sort of complex systems, underground areas that they've built, or maybe places they should explore. Another benefit of this game that I've been working on is that it uses Gluey 2, which is that graphical user interface library that I just finished a couple of weeks ago. What's really nice about it is that at runtime I could start changing some options. So here I'm typing render mode, /render mode 1, which turns everything into wireframe rendering. Not too exciting, but if I change it to render mode 2, it only turns on lighting and non-texturing rendering. So that way I can maybe debug the game at runtime. It's a really nice tool. I don't have to actually set up any sort of breakpoints in GDB, since this is currently OS X. Also, another benefit of this user interface library that I installed is I started implementing some saving and loading features. It's all accessible through the game menus. There's this little top slider which represents the time of day and then also the game time itself. Hopefully in the future I'll be able to show off some more cool features. Right now I'm working heavily on the AI. Let me switch this back into textured mode. Let's see, render mode 3. Right now I'm working on AI, but of course one of the other big needs is I really want to find an artist to help me make all of this game content without having to use placeholder textures from other games. As much as I love Minecraft, I feel kind of cheap using those placeholders for now. If you have any questions, or if you're interested in seeing what the source code looks like, remember it's all open source, and you can feel free to shoot me off an email at my website, which is cores2.com or jbryden.com. Have a good one. Thanks for watching.